going to go to Moon or if you're going to go to Mars, it's expensive and you can't do that multiple times. Flight Opportunity is a great program. It really mitigates the risk. Many times we've had payloads come through our program and they find problems with our systems. They're basically getting space environment exposure through the means of Flight Opportunities program. There's thermal problems. Heat doesn't rise in space. That's a big problem. There's two-phase flow where you've got boiling, you've got gases and liquids together. That's different in space.
Some payloads are looking to operate in microgravity, in zero gravity. Other payloads are looking to be ejected from the vehicle and come down to Earth.
Folks are using our testing to do some pretty cheap mitigations, because once this goes on its mission to a planetary body far away or coming back to Earth or what have you, usually there's no second chance. You got to do it right the first time.
Things look really good.
Things look good?
Yep, I have 10 satellites on each.
This is our SL-12 rocket. We have a 4-fin design. All the fins are canted at a half a degree of an angle that provides a spin for the vehicle to help with stabilization. As we move forward here, we have the solid rocket motor propellant. Inside here, this will all burn in approximately 12 seconds, pushing the vehicle approximately 3,700 miles an hour, which is right around Mach 5. Once when this is spent, it becomes dead weight, and we'll actually separate it into space right here. Inside here, we have our parachute tube and recovery system, along with some of our avionics hardware, flight data recorders, etc. Inside this section, we have 2 wraparound antennas. One is an S-band and the other is a GPS L1 band. In the center of this section, we have an AFTU here, which is actually horizontal, and then we have another AFTU, which is vertical. As we move forward, we get into what is known as our separation section right here. We have a cradle system that'll actually hold the Adept payload. It just seats up against our, what we call the aft sabot. After a certain time, that aft sabot will push Adept out. But before we can even do that, we have this nose cone here, which is being held in by 2 1/8-inch aircraft grade cables that will be cut at T plus 65 seconds, which will remove everything from here to the end of the nose cone, getting it out of the path of the Adept payload.
Attention launch crew, this is the launch conductor. Prepare to give your ready for pre-countdown operation start. Flight is ready. TLM
is ready.
Make sure the following switches on the EGSC box are configured to the states listed in the table below.
RBF flight is plugged. Inhibit, yes.
Yes.
The Adept payload is powered on, ready to proceed.
LCO to LC, slam stick payload is powered on.
ADEPT, like with everything in NASA, is an acronym. It stands for Adaptable, Deployable, Entry, and Placement Technology. ADEPT is a heat shield that can stow folded up like an umbrella. And then it can open up in space before it enters a planet's atmosphere and do its job as far as slowing down and safely protecting your payload. And that allows us to launch a payload in a much smaller rocket than a traditional rigid heat shield would need.
This is a suborbital vehicle, which means that it gets shot almost straight up and then essentially falls once it reaches its apogee or its highest point. For this vehicle, it will get to about 120 kilometers above sea level, well into the vacuum of space, and we can test our deployment system in a flight-like environment, just like it would be in a real mission. And then it will re-enter the atmosphere, and as it re-enters the atmosphere, it'll start to sense some G-load, and eventually will accelerate all the way to Mach 3. Heating essentially starts at about Mach 5. So 5 times the speed of sound, there's enough energy in the flow to actually start creating significant heat. There will be a little heat, but nothing significant, nothing to worry about. So this is essentially a test of stability and also the in-space deployment. We'd like to do further testing at higher altitudes where we could actually get to Mach 5 or higher, and then get some real heating as well.
We're going to proceed with payload power-up sequencing. We're going to start with Adept, and if you remove access panels on both sides of the separation section.
Adept is go for launch.
All payloads are flight mode verified.
LPS raise launcher to nominal firing position. All systems are go for launch. Check 15. Back for terminal count at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire. Pull away. 5, 10. Burn out. Good burn. Be good burn.
This vehicle does not have a parachute. It will hit the ground going approximately 50 miles an hour. What we've done is we've built in load attenuation systems into this. And so there's essentially a block of crushable foam between the nose cap and some of the critical electronics. And so if it hits right on the nose, what happens is that carriage will break intentionally and slide through that foam. And that attenuates the load. So it limits the load that the electronics see to about 1,000 Gs. And that's a range that an SD card or a typical memory will survive. If it lands at a different angle, it actually reduces the load even more because you actually start bending structure, and that's another way to attenuate load.
Right after the payload hits the ground, we deploy on a helicopter to go and recover the payloads.
Oh, wow. Angled. Bang.
We had a good time today. Everybody's really happy, and that's the end of a good day when the payloaders have their data and they're able to pull it out and start comparing it to their computer simulations and models and things like that. So a successful mission means a lot, and that's really what we're all about.
Watching this launch was super exciting, even if the payload I'm working on is not maybe as complex as the added payload. It's a part of you that goes above the command line. It's very exciting, so a bit anxious, but also relief and very, very excited when I saw that rocket roar across the sky.
Well, the technologies that NASA is working on, it's broad-reaching. It covers all kinds of different things that will benefit, the American people and really even the world in some of these technologies. Like today, the Adept, that could support a Mars mission someday.
It's a great feeling. Once you see all the hard work for months, the reward is to have a successful launch.